Completing the reaction 2.1. This is much different, new and improved from completing the reaction 2.0. Please use completing the reaction 2.1. This will be required 26 through 50 to be able to retake your completing the reaction quiz. Okay, let's keep in mind the following things. These three charts you'll be given every time. You need to think through these to know how to solve problems. First thing you need to do is decide if something is a combustion. A combustion is going to be a hydrocarbon plus an oxygen. Okay, that's how you'll know it's a combustion. That's a carbon-hydrogen piece plus an oxygen. You have to memorize that it forms CO2 plus H2O. Remember, if it's a combustion, we're going to balance oxygen dead last. Okay, if it's not a combustion, then you have to see if it's one of these six. Remember that there could be numbers with the X or numbers with the pieces that are attached with the X in any of these cases. So anywhere you see an X, there could be a subscript number with the X, or there could be there could be a subscript number with the piece that's attached to the X. And remember that here, X, generally speaking, means a metal. Okay, so you're gonna, and I call this special decomp and special synthesis, just my terminology. But if it's not one of these, then you have to see what you have. In order to use this diagram, it has to be a compound plus an element. It could be an element plus a compound, or a compound plus an element, but it has to have one of each before the arrow. If it is a compound plus a compound, you're going to go down here and decide whether or not it's a common gas or just an ordinary double replacement. Remember that these here really aren't useful to us. This just tells us the common gases. That's what these are, gases that are produced. In order for it to be a common gas, it must end, one of the two pieces of the compound must end in a sulfide, a carbonate, a sulfate, or start with an NH4. So if that's true, then also you have an acid in this case, an acid in this case, and an acid in this case, and a strong hydroxide. Remember, a strong hydroxide would be something with an OH attached, something with an OH. If both pieces are true, then you know the products it forms. It tells you exactly the products to form. Okay, let's begin and let's use these charts as I've described. Okay, this is a combustion. How do I know? A hydrocarbon plus an oxygen. So I know it's going to form CO2 plus H2O. I will provide you answers to these for balancing. I'm not going to balance them during this video to save time. All right, the next item. It is not a combustion. I'm checking to see if it's one of these. It is not one of these. I don't have an XO, an XO, or an XCl, and I have two things. So this is two things I check here. Two things. One thing I check here. So then I have to see if it's one of these. And I see a SO3 and an acid. Because I see an SO3 and an acid, it's a true, so then it tells me exactly what it's going to form down here. It's going to form SO2 plus H2O plus, it says, SO2 and H2O or HOH plus a salt. A salt is a front you haven't used. We haven't used Fe, it's in the front. And a back we haven't used, C6H5O7. All right, that is the pieces that go together. Now we have to decide how they go together. Now, we're going to think about this in several ways. I'm going to try a different method to see how we feel about this method. So I'm going to think about this fact that this is a 2 minus, and there's one of them, so this has to be a 2 plus. So then I know iron is a 2 plus, and then I have to look up C6H5O7, and I know that it is a 3 minus. So then I'm going to bring a 3 down here, and I'm going to put parentheses out around this and bring a 2 down. I'm going to crisscross reduce. Then you need to balance. Okay, next. Number 3. Number 3 is none of these. And because it's just one thing before the arrow, it has to be pieces breaking down. It's going to break into NB plus O. Then whenever they're by themselves, I have to decide if it's Brinkelhoff, yes or no. So NB is not Brinkelhoff, and oxygen is. So it'd be O2. Remember what Brinkelhoff is. It's bromine, iodine, nitrogen, chlorine, hydrogen, oxygen, and fluorine. For anything I will give you, if it's not one of these 7, and it's by itself, meaning it's not with another compound, then it's going to be by itself, no subscript numbers. If it's one of these 7 and it's by itself, like oxygen is, it has to have a 2. Then you need to balance. Again, I'm not balancing any of these. Okay, I have 2 compounds. I'm checking it's not any of these. So then I'm going to check to see if it's this. I do not have an S ending, a CO3 ending, an SO3 ending, or NH4 beginning. So then it's just a double replacement. I like to say you're going to anchor the backs and switch the fronts. So I'm going to put CN and CH O2, right? Those are the pieces that make up my ions. If you think about what I mean, I'm saying that I'm splitting it here. This is the back. The ion that makes up the back of this compound is Cn. The ion that makes the back of this compound is CHO2. Then I'm going to switch the fronts. So CO is going to go here, and Ba is going to go here. I built a new relationship. I got to figure out how they go together. This is a 1 minus, and I got to figure out what this is. And we already know this is a 2 plus, and we already know this is a 1 minus. Okay, barium can only be a 2 plus. CHO2 is a 1 minus. So I'm going to need to put a 2 around this. And then I got to figure out what cobalt is. Cobalt has multiple oxidation states. I know that this is a 1 minus times 3, which makes this a minus 6, which by default makes this a plus 6. So this is going to be 6 plus, and then I'm going to put parentheses around this, bring the 6 down, and then you cannot have pluses and minuses in your final answers, so make sure you cross through them. Okay, so I'm going to cross through this so that I don't think, as you're the reader of this problem, that you're leaving those in there. You mean those to be in there. Then you need to balance it. Okay, this one is 2 elements. So the only thing 2 elements can do is come together. So we're going to come together as Zn and O, but it's a new relationship. I need to think about how they go together. 2 plus and 2 minus. Zinc can only be a 2 plus, oxygen is always a 2 minus. So then they're going to squish together like that and then balance. Here I have just one thing before the arrow, so it's one of these special decomps or just the elements breaking apart. It is not any of these, so then it's just cobalt plus oxygen. But remember, they're by themselves. I got to think about Brinkelhoff, yes or no. Cobalt is not Brinkelhoff, oxygen is 2. Please balance. All right, here we have a compound and an element. I'm checking here. It is not any of these. So then if it's a compound plus an element, remember I'm going to go here if it's a compound plus an element. Okay, when I use this chart, I look to see who's alone. Iodine is alone, meaning it's not in a compound, it's an element. Iodine is going to kick out a part of this compound. Iodine can only kick out something like it. Iodine is in this group, so I can kick out elements in this group. Metals can only kick out metals, nonmetals can only try to kick out nonmetals. Iodine must be higher than bromine to kick it out. It is not, so then there is no reaction and nothing to balance. Example 8, element plus compound. First we check here. Okay, it is not any of these down here. So then we go to this chart. Who's alone? Potassium. Potassium is going to try to kick out silver. Potassium and silver are in the same group, or they're both metals, so they're trying to trade places. Potassium is higher than silver, so it can kick it out. So that means potassium goes with the ion that silver was with, and silver is left alone. Now, new relationships. We got to think about how they go. This is a +1 and a -1, so those look good. And Ag would not be Brinkelhoff. It's by itself. I think about Brinkelhoff, yes or no, it is not. And then you need to balance. Okay, so now we have a compound plus an element. So we're looking at this chart, and I do see that it is one of these. It's this one right here. I have an X with Cl plus an O2, so it's going to make that X, which is in this case Si with ClO3. I need to think about how they go together. I have to go back here to think about that. Remember, we can think about the fact that we know chlorine's a -1 and there's 4 of them. So it needs to be -4. That makes this a +4. So then this is +4 or 4 plus and 1 minus. So I need to put parentheses around this, put a 4 here, get rid of your charges, and please balance. Here I have a hydrocarbon plus an oxygen. You have to memorize that it makes CO2 and water. And then take a moment to balance. Remember, when we balance combustions, it's suggested that you leave oxygen to dead last. Okay, here we have 2 compounds. We're checking this chart first. It is not any of these on this chart, so now I'm looking here to see. I don't have an S ending, I don't have a CO3 ending, I don't have an SO3 ending, but I have an NH4 start, so that's a yes. And I have a strong hydroxide. I will only give you a strong hydroxide. I won't give you a weak hydroxide as a trick or anything. So it has a hydroxide, though that's strong. It tells me then it forms NH3 plus H2O plus a salt. A salt is something you haven't used yet. A front that you haven't used, SR, and a back that you haven't used, S2O3. Got to figure out how SR and S2O3 go together. This is a +2 and a -2, so they go just like that. And then you need to balance it. Number 12, I have 2 compounds. I check to see if it's in this chart. It is not. So then I'm going to see if it's here. And I do not see it here. Let me erase these as I'm thinking about both at the same time. Okay, it is not part of the common gases because we got to check them, pardon me, we got to check to see if it's part of common gases. So I see a CO3 ending, and I do see an acid. Why do I know it's an acid? Anything starts with hydrogen is an acid. Then it tells me it forms CO2 plus H2O plus a salt. A salt is a front we haven't used, in this case vanadium, and a back we haven't used, C2H3O2. We know the CO2 and H2 are good because it tells us exactly how to write them. This is a new relationship. We got to figure out how they go together. So we have to come back over here and figure out what vanadium's charge is. We know that CO3 is a -2, and there's 2 of them. So that makes this side -4, which makes this side +4. Okay, so this is going to be 4 plus and 1 minus. So this is going to get parentheses around it with a 4. Get rid of your plus and minus piece, and then you need to balance it. All right, going on to example 13. Here we have MgO. So the only thing it can be is a decomp. It's not one of these decomps. So it's going to have to be Mg plus O. By itself, magnesium is not a Brinkelhoff, oxygen is. Then balance it. We have 2 compounds. We're going to start here. We're going to see if it's one of these 2 compounds. It is not any of these. So then remember, this is where we go for 2 compounds. So I do not see an S ending, a CO3 ending, an SO3 ending, or an H4 start. So then it's just an ordinary double replacement. I'm going to bring over, what I like to say is anchor my backs and switch my fronts. So I've anchored my ions in the back. I'm going to switch my fronts. SiO3, remember we're splitting it like this to think about what I mean by the anchor the back. So here's a back and here's a back. Mn's going to go here and Fe's going to go here. Now I got to figure out what their charges are. SiO3 is a unit and it's a 2-, and there's only one of them because there's no parentheses. So this has to be a 2+. So then I know Fe is a +2, which means it's going to be 2 because H is a 1-. And then here, I know that this is a 1- and there's 7 of them, so this has to be a +7. So this is 7 plus and 2-, so there's going to be a 2 here and a 7 there, and then you're going to balance it. Okay, make sure you get either erase or scratch out all your pluses and minuses, otherwise I will think it's part and count it wrong. It cannot have pluses and minuses in the answer. Okay, here we have an element plus a compound. Again, we're checking here, okay? It is not any of these, so it has to be a possibility of being a single replacement. Remember, this is where we're going to go for element compound or compound element. We're looking at who's alone. Iron. Iron must be higher than chromium. It is not, so there's no reaction. Okay, iron is not higher than chromium, so no reaction can take place. Here I have an element plus an element, so the only thing it can be is to come together. Now this tells us to use tin as tin 4, so if this is a 4 and this is a 1, then this will be 4, and then you need to balance it. Okay, number 17, I have a compound plus an element. I'm always checking here. It's not one of those. It's not any of these right here, so then it must be a single replacement. I need to see if it actually takes place. Who's alone is fluorine. Fluorine must be higher than iodine, and it is. So then magnesium goes with fluorine, and iodine goes by itself. I jumped the gun on that a little bit, but we'll talk about why I put that there in a moment. This I have to think about crisscross reduce because it's a new relationship. This is a +2 and a -1, and then iodine, I by itself would be diatomic or one of Brinkelhoff. So I guess I2, please balance. Here we have an element plus a compound. I'm going to check to see if it's a synthesis. It is not. Who's alone? Lithium. Lithium has to kick out Au. Lithium is the highest, so it will kick it out. So lithium goes with ClO4, and Au is left alone. Okay, lithium is a +1, chlorate is a ClO4 is a -1. They're going to crisscross reduce like that. And then Au is not part of Brinkelhoff, so it is going to stay just like that. And I think I said chlorate, this is perchlorate. Not that it matters because you don't need to know that for this, but I just want to correct that myself. Again, 1 to 1, so that goes away. And then Au is not part of Brinkelhoff, so it would be just Au, not Au2. And then you need to balance. Number 19 is first compound plus compound. We always check here unless it's a combustion, and it is in fact this one right here. So it's going to be Ru plus, or Ru with OH. Now we need to figure out what Ru it is. We're going to split this, and we say that oxygen is a -2, and there's 2 of them. So that makes this a +4, because 2 times a -2 is -4. So then this is going to be a +4, and hydroxide's a -1. So we're going to put a 4 down here, get rid of our charges, and then you need to balance. This is a combustion. Why? A hydrocarbon plus an oxygen. It's going to make CO2 plus H2O. Balance your carbons, then balance your hydrogens, then deal with the oxygens dead last. Don't even look at oxygens till your carbons and hydrogens are balanced. 21, we have 2 compounds. We're checking here. It is not one of these. Okay, and this has a CO3 and an S, but doesn't have a CO3 plus an acid or an S plus an acid. So then it makes it an ordinary double replacement. Remember, we're going to anchor the backs and switch the fronts. So we're going to put S here and SO3 here. We're going to trade fronts. H is going to go here and CD is going to go here. I need to think about the charge here. We know this is a +1 and a -2, so it's going to go like this. And cadmium's a 2+ and sulfite is a 2-, so they're going to be perfect like that. Then you need to balance it. Here we have 2 compounds. We're checking here. It is not any of these. For compounds, we have to come here to see if it's a common gas or if it's just an ordinary double replacement. I do not see S ending, CO3 ending, or SO3 ending, or an NH4 start, so it's just a double replacement. We're going to anchor the backs and switch the fronts. So we're going to bring over CN, and we're going to bring over CHO2, and we're going to switch the fronts. Al is going to go here, SR is going to go here. We know this is a +3 and a -1, +3 and -1, so this is going to have a 3 for a subscript. We know this is +2 and -1, so this is going to have a 2 for a subscript. Get rid of your pluses and minuses and balance. Here we have 2 compounds, so we're trying to see if it's one of these synthesis. It is not. Do I see an S ending? No, I see a CO3 ending, but I do not see an acid, so it's not that. I don't have an SO3 ending and I don't have an H4 start, so it's just its double replacement. That means we're going to anchor the backs and switch the fronts. SiO3 plus CO3, switch, W goes here, Sn goes here. We need to figure out what their charges are. We know this is a -2, and there's 2 of them, so that makes this side -4, so this has to be tin4. So this is 4+, and that we already know this is 2-. Over here, we know carbonate is a -2, and there's 3 of them, so that's -6. So then this has to be a +6, so then we know it's +6 over here. We're going to assume oxidation state, so the plus value doesn't change for what we're going to do in this course for now. So 6 and 2 reduces to a 3. This is 4 and 2. This is going to be a 2, and then you need to balance it. Number 24, we have an element plus a compound, so we're looking here as we always start. And then because it's an element of compound, we use this chart. Fluorine is alone. Fluorine must be higher than bromine, and it is. So then we have OS with F plus Br. Now OS with F, we have to figure out how they go together. If I come over here, I saw that Br is a -6, which makes osmium in this case a +6. So this is going to be +6 and -1, so 6. And Br is by itself. We have to think Brinkelhoff, yes or no? Yes, Brinkelhoff, yes. Now balance. And then the final problem I'm going to do with you is 25. We have just a compound before, so we check in to see if it's one of these decomps or if it is just the elements breaking apart. It is one of these, so it's going to be Ti with O plus H2O. And now I got to figure out, we know H2O is fine, but how do Ti and O go together? We know O is a -2. This Ti is a -1 times 3. Hydroxide is a -1 times 3, meaning the -3 on this side. So Ti must be a +3. So +3 and a -1, I'm going to bring a 2 down and a 3 down. They don't reduce, and then I'm going to balance. Your assignment, in order to retake your quiz, is to complete 26 through 50 before you'll be allowed to retake your quiz.